Let's take a look at our last example. Hopefully you've tried it on your own first to see if you can do it. If you haven't tried it on your own, do that now. See if you can take the previous lessons and apply them here before you watch the rest of this. Once you do that, I'll walk you through how to solve it. The top web browser in 2015 was Chrome with 51.74% of the market. In a random sample of 250 people, what is the probability that fewer than 110 used Chrome? Information from our problem. We don't need the year. That's not important. 51.74% is, that's another proportion or probability. In a random sample of 250 people, that's our n. What is the probability that fewer than 110 used Chrome? Fewer than 110. Do we include 110? Fewer than? No, we're not including 110. We need n, p, and q. Then we'll need to check n times p and n times q. Right now that's as far as I'm going to write down because I don't want to calculate my mean and my standard deviation unless I'm sure that I can use that normal distribution. So n is 250 random sample. P is that probability, 51.74%. Q is 1 minus p. So if we pull up our calculators, 1 minus 0.5174, we get 0.4826. So then we would calculate n times p and n times q. 250, 5174, 250, 4826. Now before I dive too deeply into this, if your number sense is pretty confident, you might notice that 250 times 0.5 is half, 50%. 50% of 250 is 125. 51% is going to be a tiny bit more than that. I definitely have something greater than or equal to 5. Similarly for 250 times 0.48, 0.48 is almost half. Half of 250 is 125. So n times q is going to be a little bit less than 125. Again, bigger than or equal to 5. That's the point. It's important that we check that. And if you're checking it in your head, you just need to state n times p, n times q greater than or equal to 5. Normal can be used. If you need the security of the calculator, that's okay. 250 times 0.5174, 129.35. Definitely greater than or equal to 5. 250 times 0.4826, 120.65. Definitely greater than or equal to 5. This means we can use our normal distribution to approximate the binomial. Let's calculate our mean and our standard deviation. We already did the mean, n times p, 129.4. I just grab it from my calculation of n times p. And then standard deviation, n times p times q, square root 250 times 0.5174 times 0.4826. This one we do need a calculator for. I already did n times p, that's 129.4, and I need to multiply it by q, 4826. I get 62.4. Take the square root, 7.90, 7.9. And these are people. All right. Now we can write our probability statement. Probability fewer than 110. X is less than 110. Remember, this is the binomial statement. We start out with the binomial, and then we need to transition to the normal. And I don't like doing the normal until I draw my graph. So, drawing my graph, 129.4. I'm looking at 110 somewhere to the left. Since I want less than 110, I don't want to get near 110. I want left of 110. And remember, we're using boundary values, so we want 109.5 here, just below 110. So our probability will be x is less than 109.5. With technology, since this is a less than statement, we just have one norm.dist function. Norm.dist 109.5. We're going to use that same value. We're going to use that boundary value. Our mean 129.4, standard deviation 7.9, always true in the norm.dist. And let's see what this gives us. Norm.dist 109.5, boundary value to 110, below it because we're not including 110. 129.4 is our mean, standard deviation is 7.9, and always true. And we get 0.0059 for our probability. Now let's talk about this probability for a moment. 0.0059, that's a pretty small probability. Notice that Chrome had 51% of the market. We're asking what the probability that fewer than 110 used Chrome. Chrome has over half the market. So we should be expecting a small probability. And we get a small probability, 0.0059. This value is much less than 0.05. And we use this 0.05, this has come up before. We say that unlikely events have a probability less than 0.05. Since my probability is less than 0.05, having fewer than 110 people use Chrome out of 250 total is pretty unlikely. It's unlikely to happen because that probability is really small. Now, right now, we're using 0.05 as a threshold of likeliness. 0.05 and greater, 1 out of 20 or bigger, and we say that the probability is likely to occur. Less than 0.05, we say that it's unlikely. When we move into chapter 8 and beyond, this threshold of likeliness is what we call our significance level, and we can start to move that significance level around. We don't have to always pick 0.05. We could pick a different value. But until we get to chapter 8, we're going to stick with 0.05 as our unlikely threshold.